So notice the information they're giving you on the bottom of page 12. They're telling you that the cosine of theta is equal to 1/4 and that you are in quadrant 4. So unlike the problems you had to do last night for homework, they gave you two angles, you had to set up two triangles. Here you only have information to set up one triangle. So again, they're telling you the quadrant. They're telling me that I'm in quadrant 4. So I'm going to draw my reference triangle in quadrant 4. Now they're telling me that the cosine of theta is equal to 1/4. By your SOHCAHTOA, what sides of the triangle does this represent? This represents the adjacent over the hypotenuse. So again, my adjacent side is 1, my hypotenuse is 4. What do you have to do in order to find the third side? You're going to have to set up your what? Pythagorean theorem. So 4 squared is equal to 1 squared plus b squared. So 16 is equal to 1 plus b squared. When I subtract 1, I end up with 15 is equal to b squared. So b is going to be equal to square root 15. So any questions on how I came up with the third side to be square root of 15? Do I need a negative sign in front of that radical square root 15? Yes, because I'm on the negative side of the y-axis. So now, looking at the problems, I've got a 3-part question here. So what I'm going to do is, from the triangle, like I did with the other ones, I'm going to go ahead and set up the other two trig ratios. They gave me cosine of theta. Let me look at my triangle and find the sine of theta. So looking at your reference triangle, what is the sine of theta? That's going to be the opposite over hypotenuse, which is negative square root 15 over 4. Tangent of theta is the opposite over adjacent, so negative square root 15 over 1, or just negative square root 15. Always go back and double check all students take calculus, guys. Remember, you're in quadrant 4. What are the only two positive trig functions in quadrant 4? All students take calculus. It's going to be your cosine and the secant. So make sure you have negatives with the sine and the tangent ratios in quadrant 4. All right, so any questions on that? So now let's take a look at part A. They want me to find the sine of theta minus pi over 6. Notice theta is coming from my reference triangle. Pi over 6 is coming from the unit circle. So this is where now you're going to do a combination of unit circle and triangle in the same angle. What operation is happening between these two angles? We are subtracting. So treat your theta like your alpha, pi over 6 like your beta. So what I want to do from my formula sheet then is I want to look at the sine difference formula. So the sine difference formula, if you look on your blue sheet, is sine of alpha cosine beta minus cosine alpha sine beta. So I'm just going to recopy that right from my blue sheet. So that is my sine difference formula right from my blue sheet. Now what we want to do is now substitute. Anywhere you see an alpha, I'm going to plug in a theta. Anywhere I see a beta, I'm going to plug in a pi over 6. So I'm going to recopy my formula as the sine of theta cosine of pi over 6 minus cosine of theta sine of pi over 6.
And we don't put the negative in between the pi over 6?
No, because these are all multiplied together from the formula. So now substitute the values in. So anytime you're looking at the sine of theta, obviously that's not unit circle. So you're going to have to look at the triangle. What is the sine of theta ratio that I set up? I set up that sine of theta is equal to negative square root 15 over 4 times cosine of pi over 6. You can find the cosine of pi over 6. That's from the unit circle. So where am I with pi over 6? Am I in quadrant 1, 2, 3, or 4? 1. So I know that everything's positive. So I know that's going to be positive. The question is, what is the cosine ratio at pi over 6? Square root 3 over 2. Minus cosine of theta. So cosine of theta was actually given to me. Cosine of theta is equal to what? 1/4. Times the sine of pi over 6. That's going to be your 1/2. So this is where I said it's the collision of both types of problems, the unit circle and triangle problem in the same one. Any questions on that? So now, order of operations. Are we going to multiply these fractions together first, or are we going to subtract? Multiply. So negative square root 15 times square root 3 is going to give me negative square root 45 over 8. Remember, you can multiply unlike radicals together. You can't add unlikes. Minus 1 over 8. Make sure your radicals are in simplest form. Can you simplify the square root of 45 using your factor tree? You can simplify the square root of 45. What does this simplify down to? Negative 3 square root of 5 minus 1 over 8. Okay. So any questions on how you can use both the unit circle and the triangle in the same problem? Okay. So now looking down here at C, your favorite, tangents. The tangent, again, tangent of theta. So I'm going to call theta my alpha, pi over 4 my beta. What am I doing between these two angles? I'm subtracting. So what I want to do on my blue sheet is I want to look at the tangent difference formula. So on my blue sheet, my tangent's difference formula is the tangent of alpha minus tangent of beta all over 1 plus tangent of alpha, tangent of beta. Again, now substitute. Anywhere I see an alpha, I'm going to plug in a theta. Anywhere I see a beta, I'm going to plug in a pi over 4. So tangent of theta minus tangent of pi over 4 all over 1 plus tangent of theta, tangent of pi over 4. So tangent of theta, I have to look at the reference triangle that I set up. Remember, I found the tangent value to be negative square root 15. So I'm going to plug in negative square root 15. Minus tangent of pi over 4 is from the unit circle. Again, pi over 4 is in quadrant 1. What is the tangent of pi over 4? 1. All over 1 plus, again, tangent of theta I found to be negative square root 15 times 1. So I have negative square root 15 minus 1 over 1 minus square root 15. I always love it when students try to not cancel. Oh, great, I can cancel the negative square root 15s, I can cancel the 1s, and be done with it and just write a 1. Am I allowed to do that? No, you just chopped your animals all apart again. Remember, if you can't factor the numerators and you can't factor the denominators, you cannot simplify this. So don't try chopping these square root of 15's heads off. Don't try chopping the 1's off and write a negative 1. What are you going to have to do to get this in simplest form? You do have a radical in the bottom. So what are we going to have to do? Multiply the top and bottom by what? The conjugate. So I have negative square root 15 minus 1 over 1 minus square root 15. What is the conjugate of 1 minus square root 15? 1 plus square root 15. I'll do the denominators first. Remember, when you multiply a binomial and its conjugate, the outers and inners are going to cancel. Multiply your first terms together, multiply your last. Negative square root 15 times positive square root 15 is a minus 15. Now you do have to FOIL the numerators. So be careful. Negative square root 15 times 1 is a negative square root 15. Negative square root 15 times a positive square root 15, the radicals will cancel. That'll give you a minus 15. Inner terms, negative 1 times 1 is a negative 1. Last terms, negative 1 times square root 15 is a negative square root 15. So any questions on how I FOILed that numerator? So now combine like terms. Well, I have a negative square root 15 and a negative square root 15. They are like radicals. That'll give me negative 2 square root 15. Negative 15 minus 1 is a negative 16. Over 1 minus 15 is negative 14. Remember, after you do your conjugate work, see if now you can simplify your fraction. Can you divide a common factor out of every single term? You can divide out a what? 2. Even better, you can divide out a negative 2. So that's going to give me square root of 15 plus 8 all over 7. So there's your final answer. Okay? Like I said, with the tangents, yes, you're going to have the radicals to possibly rationalize those denominators and or complex fractions. Yes? Yep. So any questions on those? All right.